They once roamed the plains of Ice Age North America, built like tanks, hunting in packs, tearing through bison, horses, and even mammoths. The dire wolf wasn't just some prehistoric version of today's gray wolf. It was heavier, more muscular, and far more terrifying. For over 10,000 years, it was the apex predator of its time, until it vanished, wiped out in a mysterious extinction event at the end of the Pleistocene. For centuries, the only place these creatures existed was in fossil beds, ancient legends, and the occasional fictional cameo in fantasy shows. But that's no longer the case, because in 2025, scientists made an announcement that shook the world of genetics, conservation, and ancient life. The dire wolf, long extinct, had been brought back, or at least something very close to it. And that's where things start to get complicated. Let's begin with what we know about dire wolves. They lived primarily during the late Pleistocene epoch, roaming across much of North and South America. Unlike gray wolves, which are agile and lean, dire wolves were stockier, with shorter legs, broader skulls, and massive jaw muscles designed to crush bone. Fossil evidence shows they often scavenged, but also likely took down large prey in coordinated packs. They were not, as often portrayed, just oversized wolves. In fact, modern DNA analysis shows they weren't even closely related to gray wolves. They were a distinct genus altogether, Inoceondirus, more closely aligned with jackals than wolves, which means for decades scientists assumed cloning them back into existence was virtually impossible, until now. In April 2025, a Texas-based biotech company called Colossal Biosciences released a press statement that made headlines worldwide. They claimed to have produced 3 living wolf pups, named Romulus, Remus, and Khaleesi, that had been genetically engineered to resemble the dire wolf. The announcement was met with shock, excitement, and immediate skepticism. Could they really have brought back one of the Ice Age's most fearsome predators? The answer lies in a mix of modern biology and a bit of Jurassic Park-style ambition. The team started by extracting DNA from 2 fossilized specimens, a 13,000-year-old tooth found in a tar pit and a 72,000-year-old partial skull recovered from permafrost. These ancient samples provided a limited but invaluable window into the dire wolf's genetic code. From there, researchers identified 14 genes that they believed were responsible for the physical traits that defined the dire wolf: its size, skull shape, jaw strength, fur density, and vocal structure. They then used CRISPR gene editing technology to splice these genes into the embryos of modern gray wolves. These edited embryos were implanted into domestic dog surrogates, Labrador retrievers in fact, chosen for their temperament and maternal reliability. After months of monitoring and a successful birth, 3 healthy pups were born. They were larger than typical wolf pups, with broader snouts, deeper vocal tones, and a noticeably thicker build. Photographs and early videos showed animals that, at a glance, looked eerily similar to what we imagine a dire wolf would have looked like. But this is where the celebration starts to crack. While these animals may look like dire wolves, genetically they are something else entirely. Only 14 genes were edited, a tiny fraction of the thousands that would make up a full dire wolf genome. The vast majority of their DNA still belongs to the gray wolf lineage, so what we're seeing isn't a cloned dire wolf, but rather a heavily modified wolf hybrid, with some traits resembling its extinct relative. It's a bit like taking a Honda Civic, replacing the hood, headlights, and tires to look like a 1969 Mustang, and then calling it a Mustang. Sure, it might fool the casual observer, but under the hood, it's still a Civic. In the same way, Romulus, Remus, and Khaleesi might look like dire wolves on the surface, but deep inside, they're not the same predator that once roamed ancient America. And that raises some serious questions. First, there's the scientific question: does this count as de-extinction? Colossal Biosciences argues that this is a necessary first step, a prototype, if you will, toward eventually recovering more of the dire wolf's genome. They plan to edit dozens, maybe hundreds more genes in future generations, gradually moving closer to an authentic recreation. Critics, however, argue that unless the entire genome is restored, these animals are merely imitations. Fascinating, yes, but not true resurrections. Then there's the ethical question. What are the consequences of bringing back an apex predator in a world that no longer has the ecosystem it once thrived in? The Ice Age landscape is gone. The megafauna it hunted, camels, giant sloths, mastodons, are extinct. If these engineered predators were ever released into the wild, where would they fit? What would they eat? How would they interact with modern ecosystems, or worse, with people? And finally, there's the philosophical question. Even if we could bring back extinct creatures, should we? Some conservationists see this work as a distraction from more urgent efforts, like protecting endangered species that still exist. Others worry about unforeseen consequences, genetic instability, unintended suffering, or ecological disruption. And then there's the unsettling idea of turning nature into a customizable toolkit, where extinction isn't permanent and ancient life becomes something we can remix and repurpose. But here's what most people miss about this story. It's not just about dire wolves. This breakthrough is part of a much larger trend. Colossal Biosciences isn't stopping here. They've already announced plans to revive the woolly mammoth using Asian elephants as surrogates. They're exploring the genetic recovery of the dodo bird. They're building software to model ancient genomes in virtual environments before editing even begins. What we're witnessing is the dawn of a new era, one where extinction may no longer be the end of the story, but the beginning of something far stranger. And if this technology advances, if we go from 14 edited genes to 1400, we may one day walk beside creatures that vanished millions of years ago. But whether those creatures are truly the same as what we lost, or something altogether new, remains an open question. So what does this mean for the future? If we perfect this technology, do we start resurrecting species lost to human activity? Do we create hybrid predators for conservation purposes? Could we, one day, see herds of recreated mammoths roaming Siberia to help reverse climate change, as some scientists suggest? Or are we opening a door that, once open, we can never close? A door to a world where biology is rewritten and nature becomes a series of design choices. So yes, the dire wolf is back, in a way, but something's not quite right, and what comes next might be even more surprising. But until then, you won't want to miss this deep dive into the dire wolf itself.